So finding solution in competitive programming is not just converting your logic into the code. You need to find a logic that runs very quickly, most efficient one, and you should be able to write that. That's where the main challenge is. And that's what makes competitive programming very interesting. So we are going to look at constraints and estimations. See, you see a problem. You develop a logic. You convert that logic into the code. You type that code. You run on the given input. Then you submit, right? This is the flow that we have in a contest. Once the code is submitted, you get time limit exceed. Why is that? Well, because your logic was correct. That's why it worked on the given input. But the time it took to execute on the full input size was larger than the provided. That means your logic was correct, but it wasn't the efficient. And that's where you failed. That's why majority of the people get time limit exceed. How can we solve this particular problem? Well, it is possible to compute the runtime of algorithm even before implementing it. Well, you can stop at this particular position itself. Once you have the logic, you should be able to compute the time complexity for it without even writing the code. Once you compute the time complexity for that particular logic, you understand whether it fits into the given constraints or not. And that's what we are going to look into this particular video. Usually, some 100 into a million operations get performed in 1 second. Now we can guess the required runtime of the algorithm based on the input constraints and the time limit that they have provided. So every single problem they provide the limit. Like the array length cannot be greater than 10 to the power 5. Something like that. So your n is limited to 10 to the power 5. So this is the constraint that you have. They also provide the time limit for algorithm to run. Sometimes it's 1 second, sometimes it's 2 seconds. So based on the input constraint and the time limit that they have provided us, we can figure out an algorithm that will be accepted. Remember, time complexity is only an estimation. It doesn't actually tell you how many operations your algorithm is performing. For example, n by 2 operations, we write time complexity as O of n. 5 into n, also we write time complexity as O of n. Now let's look at the input constraints and the time limit. Now let's say they give us time limit as 1 second or 2 seconds, correct? And input size or the constraint are like this. See, this n factorial is greater than 2 to the power n. 2 to the power n is greater than n cube. N cube is greater than n squared. N squared is greater than n. N is greater than root n. Root n is greater than log n. And log n is greater than constant time complexity. Also, n square is also greater than n log n. So if time limit is 1 second or 2 seconds and input size is less than or equal to 10, then you can go for any algorithm that has time complexity as n factorial or 2 to the power n or maybe root n. You can go with any of the algorithm that has this time complexity. At max you can go for n factorial. Let's say n is 20. Then you can go for 2 power n. But you cannot go for n factorial because 20 factorial will be very huge. So you can go for 2 power n. So what I am trying to tell you that given the input constraint, you can define what is the maximum time complexity your algorithm can have. That is the maximum. You can also have a solution in O of n and that is perfectly fine. Go with O of n solution then. But this is the maximum that is allowed for n less than or equal to 20. For n less than or equal to 500, you can go for the cube. For 5k, you can go to n squared. If n is less than or equal to 10 to the power 6, then you can go for n log n. Now let's say it's 10 to the power 9 or 10 to the power 10, then you can go for root n because this value will be roughly around 10 to the power 5, something like that. And if n is very large, then you have to develop a solution in log n or in constant amount of time. Our solution cannot be dependent on the value of n because value of n is very large. So most likely you will develop a constant time complexity solution. Or we can have log n as well. Let's say n is 10 to the power 18. Then log n base 2 is just going to be around 60 only. Once you have the logic and that logic is giving you the correct answer and also the time complexity of that logic is appropriate compared to the input size, then you can go for the code